Imagine standing on the precipice of the greatest journey humanity has ever embarked upon, where the boundary between the known and the unknown blurs, and the mysteries of the cosmos beckon us forward. This is not just a story of exploration. It's the narrative of our species, stretching its capabilities beyond the confines of Earth, reaching out to touch the face of our nearest celestial neighbor, the Moon. As we stand on the cusp of a new era in lunar exploration, driven by groundbreaking scientific curiosity, unparalleled technological advancements, and a collective aspiration for the stars, we invite you on a voyage that promises to redefine our understanding of the universe and our place within it. Join us as we delve into the reasons behind the world's renewed interest in the Moon, exploring its potential to inspire, challenge, and expand the horizons of human possibility. Welcome to the next chapter in the grand saga of human exploration, where every footprint on lunar soil marks a leap towards the future of humanity in the cosmos. Start by painting a vivid picture of humanity's age-old fascination with the Moon, highlighting how it has been a constant presence in the night sky, inspiring myths, guiding explorers, and sparking the imagination of scientists and poets alike. Transition into the era of telescopic observations by Galileo, leading up to the space race of the 20th century. Detail the monumental achievement of the Apollo missions, emphasizing the bravery, ingenuity, and spirit of exploration that propelled humanity to the lunar surface. Convey the sense of wonder and achievement felt around the world when the first humans set foot on the Moon, marking a pinnacle of human exploration and scientific endeavor. Shift to the present day, where a new chapter in lunar exploration is being written. Discuss the technological advancements and international collaborations fueling this resurgence. Highlight the role of both government space agencies like NASA's Artemis program and private companies like SpaceX and Blue Origin in rekindling the dream of returning to the Moon. Point out the scientific, economic, and strategic motivations driving this renewed interest, including the desire to establish a sustainable human presence on the Moon and to use it as a stepping stone for future missions to Mars and beyond. Finally, delve into the significance of understanding the why behind this new lunar frontier. Discuss the multifaceted motivations including scientific curiosity, the search for resources, such as water ice and rare minerals, national prestige, and the human drive to explore the unknown. Highlight the potential benefits of lunar exploration, such as advances in space technology, deepening our understanding of the cosmos, and inspiring the next generation of scientists, engineers, and explorers. Conclude with a reflection on how revisiting the Moon can help address Earth's challenges and expand humanity's horizon, setting the stage for the exciting possibilities that lie ahead in the cosmos. The quest for lunar resources is not just a pursuit of material wealth beyond our world. It represents a leap towards sustaining life and technological advancement in space. The Moon, with its untapped resources, stands as a silent witness to the solar system's history and a key to unlocking a sustainable future in space exploration. Begin this section by introducing helium-3 as a rare isotope on Earth, but more abundant on the Moon's surface, embedded in the lunar soil by the solar wind over billions of years. Discuss the potential of helium-3 as a fuel for nuclear fusion, a process that promises to provide a cleaner, safer, and almost limitless energy source compared to current nuclear power generation methods. Unlike the nuclear fission reactions used today, fusion with helium-3 produces minimal radioactive waste, positioning it as an ideal energy solution for an environmentally conscious future. Highlight the scientific and engineering challenges that must be overcome to harness fusion energy, from the extraction of helium-3 from lunar regolith to the development of fusion reactors capable of using this fuel efficiently. Emphasize the transformative impact that achieving fusion energy would have on society, from reducing our reliance on fossil fuels to powering long-duration space missions, making it a key driver behind the exploration of lunar resources. Transition to the discovery of water ice in permanently shadowed craters at the Moon's poles, a finding that redefined our understanding of the lunar environment and its potential for supporting human exploration. Explain how water ice can be used not only for life support, providing astronauts with drinking water and oxygen, but also as a component in the production of rocket fuel, hydrogen and oxygen, through electrolysis. Discuss the implications of using the Moon as a pit stop for future space missions, where water extracted from the lunar surface could fuel spacecraft for deeper space exploration, significantly lowering the cost and complexity of missions to Mars and beyond. Describe the technologies and missions currently being developed to prospect, extract, and utilize lunar water ice, such as robotic landers and rovers equipped with drilling rigs and water extraction systems. The moon's geology holds the secrets to not only its own history, but also offers clues about the early solar system. This section delves into how recent missions and research are unraveling these mysteries, providing insights that could have profound implications for science and industry. Start this segment by outlining the moon's formation theories, including the giant impact hypothesis, which posits that the moon was formed from the debris left after a Mars-sized body collided with the early Earth. This sets the stage for understanding the moon's significance in studying planetary formation and evolution. Discuss how the moon's relatively unchanged surface, compared to Earth's, serves as a time capsule for the solar system's history, offering a pristine record of the celestial impacts and geological processes that shaped the early planets. Highlight the role of lunar missions in mapping the moon's surface, identifying its diverse geological features, from vast maria and highlands to deep craters and ancient lava tubes. Describe how samples returned from the lunar surface have helped scientists date the moon's formation, understand its internal structure, and study its volcanic activity. Emphasize the importance of these findings in refining models of planetary evolution and the dynamics of terrestrial planets. Transition to the exciting prospects of discovering new minerals and compounds on the moon, which could not only expand our geological knowledge but also have practical applications. Discuss how the unique conditions of the lunar environment, such as its low gravity and lack of atmosphere, might lead to the formation of minerals that are rare or non-existent on Earth. Detail the implications of such discoveries for materials science and technology. For example, new minerals could offer superior properties for electronics, construction materials for future lunar habitats, or even catalysts for chemical processes. Highlight ongoing and future missions equipped with sophisticated instruments designed to analyze the lunar soil and rocks at a molecular level, searching for these unknown minerals and compounds. This segment delves into the cutting-edge technologies propelling humanity's return to the moon and beyond, showcasing how these innovations are paving the way for a new era of exploration. The narrative will explore the synergy between human ingenuity and the harsh demands of space, highlighting advancements that promise to make the lunar frontier accessible like never before. Begin with an overview of how spacecraft design has evolved since the Apollo era, emphasizing the integration of modern materials, propulsion technologies, and computational advancements. Discuss the development of new spacecraft that are more efficient, reliable, and capable of supporting human life in deep space for extended periods. Highlight specific innovations such as reusable rocket technology, which has revolutionized space travel economics, and the development of powerful new engines designed for deep space missions. Explain how these technological advancements have not only reduced costs, but also increased the frequency and feasibility of lunar missions. Include examples of next-generation spacecraft, like NASA's Orion capsule or SpaceX's Starship, designed for long-duration missions and capable of carrying larger crews and payloads to the moon. Emphasize the role of international cooperation in these developments, showcasing joint missions and shared technologies that underscore the collaborative nature of modern space exploration. Shift focus to the role of robotics in unlocking the moon's secrets, starting with the pioneers of lunar rovers and progressing to today's sophisticated autonomous systems. Describe how robotics has transformed lunar exploration, allowing scientists to reach previously inaccessible areas, conduct complex scientific experiments, and lay the groundwork for human missions. Highlight the use of AI and machine learning in enhancing the autonomy of these robots, enabling them to navigate challenging terrain, make decisions, and perform tasks with minimal human intervention. Discuss the variety of robotic missions, from rovers and landers to orbiters and impactors, each designed with specific objectives such as mapping the lunar surface, searching for water ice, or studying the moon's geology. Explain how these missions are critical for preparing for human settlements, from identifying resources to testing technologies for extracting water and building infrastructure. The pursuit of a sustainable presence on the moon involves not just short-term missions, but the establishment of infrastructure that supports long-term human activity. This section explores the innovative technologies designed to utilize lunar resources and create habitats that could support life far from Earth. Begin with an explanation of in situ resource utilization, ISRU, a critical technology for sustainable space exploration. ISRU refers to the practice of extracting and processing local resources to support human missions, reducing the need to transport materials from Earth. Highlight the significance of this technology in enabling longer missions, reducing costs, and increasing the autonomy of lunar explorers. Focus on the use of ISRU for fuel production, one of the most promising applications. Discuss how scientists and engineers are developing methods to extract water ice from the lunar regolith and convert it into hydrogen and oxygen, the components of rocket fuel. This process could revolutionize space travel by allowing ships to refuel on the moon, significantly lowering the cost of missions beyond lunar orbit and facilitating a cislunar economy. Include descriptions of prototype machines and experiments designed to demonstrate these capabilities, such as NASA's Viper rover, which aims to map water ice at the moon's south pole. Emphasize the challenges faced in this endeavor, from the technical complexities of extracting and purifying water ice in extremely cold, permanently shadowed regions, to the engineering challenges of scaling up production for practical use. Transition to the topic of creating long-term habitats and infrastructure on the moon. Discuss the importance of designing structures that can protect humans from the harsh lunar environment, including extreme temperature fluctuations, radiation, and micrometeorite impacts. Describe the innovative approaches being considered, from using regolith to 3D print habitat structures, to designing inflatable modules that can be buried under the surface for added protection. Highlight ongoing research and development efforts aimed at creating self-sustaining habitats that recycle air and water, grow food, and use local materials for construction and repairs. Mention the international and commercial partnerships working on habitat designs, testing them in simulated lunar environments on Earth to ensure they can withstand the real conditions on the moon. The narrative of lunar exploration is increasingly becoming a story of global cooperation. As nations around the world set their sights on the moon, international partnerships are forming, blending diverse expertise, resources, and visions into a unified effort to return to our celestial neighbor. This section explores the dynamics of these collaborations, their objectives, and the potential for establishing a joint lunar outpost. Begin by discussing the formation of international partnerships, highlighting key alliances such as the Artemis Accords, initiated by NASA, which aim to establish a common set of principles to govern the exploration and use of outer space for the benefit of all humanity. Outline how these partnerships bring together space agencies from Europe, Asia, and the Americas, each contributing unique technologies, scientific goals, and resources. Emphasize the significance of these collaborations in pooling global resources and expertise, which not only accelerates the pace of lunar exploration, but also helps distribute the immense costs and risks associated with space missions. Mention specific examples of international missions, like the Lunar Gateway, a planned space station in lunar orbit intended to serve as a multi-purpose outpost accessible to a variety of international spacecraft. Shift to the shared goals and benefits these partnerships offer. Discuss how collaboration in lunar exploration serves scientific pursuits, such as understanding the moon's formation and its geological history, which are fundamental to comprehending Earth and the broader cosmos. Highlight the technological advancements spurred by these collaborative efforts, from new propulsion systems to life support technologies, which have applications both in space and on Earth. Additionally, delve into the geopolitical and economic benefits of international cooperation in space. Explain how participating in lunar exploration can enhance a country's technological stature, inspire the next generation of scientists and engineers, and potentially unlock new commercial opportunities, from mining lunar resources to space tourism. As humanity looks to the moon not just as a destination, but as a catalyst for broader space exploration and economic expansion, the lunar landscape is increasingly viewed through the lens of opportunity. This section explores how the moon serves as a critical stepping stone for future space endeavors and a fertile ground for emerging economic activities, including tourism and commercial ventures. Begin by illustrating the moon's role as an essential launch pad for missions to Mars and beyond. Describe how the experience and knowledge gained from establishing a human presence on the moon will inform the development of technologies, life support systems, and strategies needed for the longer journey to Mars. Highlight the strategic importance of the moon in testing habitats, rovers, and ISRU technologies in a relatively accessible environment, reducing the risks and uncertainties of deep space missions. Emphasize the moon's potential to act as a staging ground, where spacecraft bound for Mars can be assembled, fueled, and launched with resources harvested from the lunar surface. This approach not only makes missions to Mars more feasible and cost-effective, but also demonstrates the moon's pivotal role in humanity's outward expansion into the solar system. Shift focus to the economic implications of lunar exploration. Discuss the prospects of mining the moon for precious resources like helium-3, rare earth elements, and water ice, which could support both lunar operations and Earth-based industries. Explore how the development of these resources could lead to new economic sectors, including the manufacturing of space-based solar power stations that beam clean energy back to Earth. Detail the potential for the moon to host research facilities that take advantage of its unique environment for scientific experiments, pharmaceutical development, and materials testing. These endeavors not only promise substantial economic returns, but also foster the growth of knowledge and technology that benefits society at large. In the arena of space exploration, the moon occupies a unique position at the intersection of national prestige and strategic interests. This section delves into the competitive dynamics among nations vying for leadership in space and examines the strategic advantages conferred by a presence on the lunar surface. Begin by setting the stage for the historical context of space exploration as a symbol of national capability and technological prowess, harking back to the Cold War era's space race between the United States and the Soviet Union. Highlight how, in the 21st century, the arena has expanded to include emerging spacefaring nations like China, India, and a consortium of European countries, each seeking to assert their technological, scientific, and exploratory capabilities beyond Earth's bounds. Discuss the motivations driving this competition, from the desire to inspire national pride and foster a sense of unity to the pursuit of economic and scientific gains. Highlight how achievements in space exploration, such as successful lunar missions, satellite deployments, or human spaceflight, serve as benchmarks of national achievement and technological sophistication on the global stage. Shift the narrative to the strategic implications of establishing a presence on the moon. Outline how control over lunar resources, such as potential water ice reserves for life support and rocket fuel, and rare minerals, could become a significant advantage for nations looking to extend their influence into space. Such resources could underpin future space exploration missions and even support economic activities in space and on Earth. Further, discuss the military and security dimensions of a lunar presence. Explain how bases on the moon could serve dual purposes, not only as scientific and exploratory hubs, but also potentially as strategic outposts. While space treaties currently emphasize peaceful uses of outer space, the strategic high ground of the moon offers theoretical advantages for communications, navigation, and even surveillance capabilities, sparking debates on space militarization and the need for international space law updates. Expanding on the strategic advantages of a lunar presence, monitoring Earth from the moon emerges as a compelling application with far-reaching implications. This function could enhance our capabilities in Earth observation, environmental monitoring, and even global security. The unique vantage point of the moon offers a new perspective for observing Earth's climate patterns, natural disasters, and environmental changes over time. By establishing observation posts or satellites in lunar orbit, scientists could leverage the moon's stable position to collect long-term data sets that are invaluable for climate research, disaster preparedness, and managing Earth's natural resources. Discuss the potential for deploying advanced telescopes and sensors on the moon, free from Earth's atmospheric distortions and light pollution. These instruments could provide clearer and more comprehensive views of Earth, offering insights into atmospheric composition, ocean health, and terrestrial ecosystems. Highlight the synergy between lunar-based Earth monitoring systems and existing satellite networks, emphasizing how this integration could lead to unprecedented global surveillance capabilities, enhancing efforts in climate change mitigation and environmental stewardship. The moon's role as a strategic outpost extends beyond Earth observation, serving as a critical waypoint for missions deeper into the solar system. Its lower gravity, well compared to Earth's, makes it an ideal staging area for launching missions to Mars, asteroids, and beyond. Discuss how the development of infrastructure on the moon, such as fuel depots, manufacturing facilities, and launch platforms, could dramatically reduce the costs and logistical challenges of deep space exploration. Explore the concept of the moon as a testing ground for technologies and life support systems intended for use on Mars and other celestial bodies. The lunar environment offers a proximate yet challenging setting to simulate extended human presence on other planets, from habitat sustainability to ISRU. Highlight the strategic importance of these lunar missions in preparing humanity for the next giant leap in space exploration, drawing parallels to historical explorations on Earth that relied on strategic waypoints for successful navigation and resupply. The journey to explore the cosmos is not just a series of technical achievements, but a profound endeavor that captures the human imagination and spirit. This section underscores the importance of fostering public interest in space exploration and the role of educational initiatives in inspiring future innovators. Begin by exploring the ways in which space exploration naturally generates excitement and curiosity among the public. Highlight historical moments like the Apollo moon landings that united millions around the world in awe and wonder. Discuss contemporary efforts to engage the public, such as live-streamed rocket launches, social media campaigns by astronauts aboard the International Space Station, and interactive apps that allow users to track satellites and space missions in real time. Emphasize the importance of storytelling and making space exploration relatable and inspiring. Through documentaries, science fiction, and public talks by astronauts and scientists, the stories of human courage, innovation, and discovery connect with audiences on a personal level, fostering a sense of involvement and support for space endeavors. Mention how these narratives not only entertain but also educate the public about the challenges and triumphs of space exploration, highlighting the tangible benefits it brings to society, from technological advances to a deeper understanding of our place in the universe. Shift the focus to the educational impact of space exploration, detailing how it serves as a powerful catalyst for learning and inspiration. Discuss initiatives like STEM, science, technology, engineering, and mathematics, programs that leverage space-related topics to engage students, sparking interest in subjects that are foundational to future careers in space exploration and related fields. Highlight partnerships between space agencies, educational institutions, and nonprofits to bring space science into classrooms through projects, competitions, and hands-on activities. These efforts demystify space technology and science, making them accessible and exciting to students of all ages. Share success stories of students who were inspired by such programs to pursue careers in aerospace, robotics, or environmental science, illustrating the long-term impact of these educational initiatives. The expansion into space is driven not only by curiosity and the desire for knowledge, but also by the imperative to safeguard the future of humanity. This section delves into the environmental challenges facing Earth and explores the potential of the Moon as a sanctuary in the broader strategy for human survival. Start by painting a picture of Earth as a uniquely hospitable but fragile ecosystem, currently facing unprecedented threats from climate change, biodiversity loss, and resource depletion. Highlight the importance of space exploration in providing critical insights into Earth's environmental systems, offering a vantage point for understanding and mitigating these challenges. However, underline the argument made by some scientists and thinkers that, in the long term, humanity's survival may depend on becoming a multiplanetary species to hedge against existential threats, such as asteroid impacts, supervolcanic eruptions, or anthropogenic disasters. Discuss the role of space technology and exploration in enhancing our ability to monitor Earth's climate, manage natural resources more effectively, and develop technologies that can mitigate environmental impacts. Emphasize that while space exploration offers tools to protect and preserve Earth's environment, it also prepares humanity for the possibility of life beyond our home planet. Shift the focus to the Moon as the nearest and most logical first step in humanity's expansion into the cosmos. Outline the Moon's potential as a site for establishing permanent human habitation, serving not just as a scientific and exploratory outpost, but also as a potential safe haven for humanity. Discuss the practical considerations of lunar colonization, including the availability of resources such as water ice, which could support life and fuel production, and the challenges of creating habitable environments in the harsh lunar conditions. Explore the strategic advantages of the Moon in the context of human survival. The Moon's proximity to Earth makes it a feasible destination for back-and-forth missions and the transportation of materials and people, laying the groundwork for a sustainable off-world community. Highlight ongoing research and proposals for creating self-sustaining lunar bases that utilize local resources, protect inhabitants from space radiation, and provide for basic needs through regenerative life support systems. Exploring the moon, while exciting and full of potential, comes with a set of significant technical challenges that must be navigated to ensure the safety and success of missions. This section focuses on the technical hurdles, specifically the critical issue of radiation exposure, which astronauts and equipment face when venturing into lunar space and the lunar surface. Start by explaining the nature of the radiation environment in space, which is vastly different from that on Earth. Without Earth's magnetic field and atmosphere to provide protection, the moon is bombarded by cosmic rays and solar radiation, posing a significant risk to human health and electronic equipment. Discuss the sources of this radiation, including galactic cosmic rays, GCRs, solar particle events, SPEs, and radiation from the Van Allen belts. Detail the health risks associated with prolonged exposure to space radiation, which include increased risk of cancer, damage to the nervous system, acute radiation sickness, and potential harm to future offspring. Highlight the challenges this poses for long-duration lunar missions and the importance of developing effective radiation shielding and monitoring techniques to protect astronauts. Next, explore the technological solutions currently being researched and developed to mitigate these risks. These include habitat designs that incorporate regolith-based shielding, wearable radiation protection suits, and the development of pharmaceutical countermeasures to minimize radiation damage to human tissue. Mention the role of predictive models and real-time monitoring systems that help manage exposure during solar particle events by providing early warnings and enabling astronauts to seek shelter. Delve into the complexity of developing and maintaining life support systems for lunar habitats, crucial for providing astronauts with a breathable atmosphere, potable water, and nutritious food over long durations. Explain the need for these systems to be highly reliable, efficient, and regenerative, minimizing waste and recycling resources as much as possible to support life far from Earth. Discuss the engineering challenges involved in creating closed-loop life support systems that can operate in the harsh lunar environment. These include maintaining air quality, managing carbon dioxide levels, purifying water, and growing food in space. Highlight innovative solutions being explored, such as hydroponic and aeroponic agriculture for food production, advanced water filtration technologies, and systems for capturing and recycling human waste. Emphasize the importance of redundancy and fail-safes within these systems to prevent catastrophic failures. The loss of life support, even for a short period, could be fatal on the moon, underscoring the need for robust designs and thorough testing on Earth and in orbit before deployment to lunar habitats. Transition to the geopolitical landscape of lunar exploration, which, while offering unparalleled opportunities for international cooperation, also harbors potential for tensions. Discuss how the competition for resources, territorial claims, and the strategic military value of the moon could complicate relationships between spacefaring nations. Highlight the importance of treaties like the Outer Space Treaty and the Artemis Accords in establishing a framework for peaceful exploration, but also note the challenges in enforcing these agreements and ensuring equitable access to lunar resources. Explore the potential for collaboration to mitigate these tensions, emphasizing how shared missions, research projects, and governance frameworks can foster goodwill and mutual benefits. However, acknowledge the complexity of aligning diverse national interests, regulatory standards, and visions for lunar exploration. Finally, address the ethical implications of exploiting lunar resources. Raise questions about the preservation of the moon's natural state versus the human drive to explore and utilize extraterrestrial resources for economic gain and survival. Discuss the responsibility of current generations to explore and use the moon sustainably, ensuring that its scientific, cultural, and environmental values are respected for future generations. Consider the perspectives of scientists, environmentalists, indigenous peoples, and other stakeholders in the debate over lunar resource exploitation. Highlight the need for comprehensive international agreements that not only regulate resource extraction, but also protect areas of historical, scientific, or cultural significance, such as the Apollo landing sites. As we conclude this exploration of the moon's mysteries, challenges, and the potential it holds for humanity, let's revisit the key drivers behind the renewed global interest in lunar exploration. This resurgence is fueled by a combination of scientific curiosity, technological advancements, economic opportunities, international prestige, and the strategic imperative for human survival. The moon's allure lies not only in its proximity and accessibility, but also in its capacity to serve as a living laboratory for scientific research, a proving ground for new technologies, and a stepping stone for deeper space exploration. The quest to return to the moon is propelled by the desire to understand our cosmic origins, assess its resources for sustainable exploration, and test the limits of human ingenuity in overcoming the harsh conditions of space. Moreover, the moon represents a canvas for international collaboration, offering a platform for nations to work together towards common goals in space, fostering peace and mutual understanding on Earth. The journey to the moon is just the beginning of a new era in space exploration. This endeavor has broader implications for our future, signaling a shift towards becoming a multiplanetary species. The technologies, partnerships, and policies developed for lunar exploration are laying the foundation for missions to Mars and beyond, opening up new realms for discovery and settlement. The exploration of the moon challenges us to think about our place in the universe and our responsibilities as stewards of celestial bodies. It prompts us to confront ethical considerations about exploitation and preservation, urging us to establish guidelines that ensure the responsible use of space resources. Moreover, the renewed focus on the moon has the power to inspire generations, sparking interest in STEM fields and encouraging a new wave of scientists, engineers, and explorers committed to pushing the boundaries of what's possible. The vision of a future where humanity thrives on the moon and beyond serves as a testament to our collective ambition, resilience, and creativity.